Yeah, thank you. Thank you very much, and I wish you all a very warm welcome. I'm glad to be here again at the JKU. I studied at the JKU quite a while ago, and it's always good to come here and talk to you. Talk to you about a topic that is very near to my heart, microservices and DevOps. And as Rainer said, it's near to my heart because my area of expertise, the area that I mainly work in, is cloud, software as a service, and things like that. 10 years ago, Karen Huber and I founded Software Architects, our latest venture, and our idea was to build a company centered around building software as a service solutions based on cloud computing technologies. 10 years ago, that wasn't as obvious as it is today. 10 years ago, many people thought we were crazy giving away our servers, moving them to Microsoft, Amazon, Google, or wherever. But we thought it is a good idea because we are, from the bottom of our hearts, we are software developers. We are the dev people, not the ops people. We like writing code. We do not like installing servers and maintaining servers. And therefore, cloud was a very interesting topic for us, and this was the reason why we started our business in the cloud, and we have been doing that for 10 years, and we are still very happy in that area. So what my company primarily does is we are developing software as a service solutions ourselves, and we are helping small, medium, and quite large companies transitioning to the world of cloud computing, of software as a service, platform as a service, and so on. Our customers are spread mainly all over Europe, but we have some customers abroad too. Our topic today, I was invited by Rainer to speak today about some aspects of microservices. And microservices is a topic that is currently quite hot. If you go to practitioner conferences, I've been in Munich for the last 2 days at a conference which is called Microservices Summit, and I've talked to a lot of people there, quite large enterprises, and everybody wants to go into that area of microservices. And I was invited to speak about microservices, and today I really want to focus in the next, 55 minutes or so, I want to focus on why microservices without DevOps is nearly not possible, or at least very difficult. So I would like to focus in the next hour on the combination of microservices and DevOps and why you need both in order to be successful with the microservice architecture pattern. Before we go into the details, let's quickly recap what microservices are all about. Don't be afraid, I'm not going to show you a lot of slides. I know you are all quite familiar with this topic, so you know in theory what a microservice is. It is a set of distributed services working together and founding a software solution overall. So we are splitting a monolithic application into smaller services, and we can communicate with these services, or these services communicate with each other using platform-independent, technology-independent services, protocols. This is what I meant. That's what microservices is. Sounds obvious, sounds quite simple. In practice, this is not as simple as it sounds. Let's quickly think about why microservices is interesting and why microservices is maybe not the solution, not the silver bullet, not the solution to everything. Let's start with a positive thing. I always like to start thinking about why should I go into that direction before I dive deeper into a certain material, and let's do that for the topic of microservices. Imagine I would ask you this question. Let's start with the question that I ask you. You're starting in a new company. This company is currently deep into large monolithic applications, and you as a student from the Johannes Kepler University, you go there and you tell them, hey, Microsoft is the coolest thing you've ever seen, and your future boss asks you, why? What would you answer? Why is microservices better than having a monolithic application? Any ideas?
Simpler to maintain.
It's simpler to maintain. Why is it simpler to maintain? What is simpler to maintain? Let's be a little bit more specific.
There are many small services and
Okay.
one monolithic.
Okay.
So in the big one, if you have to consider the whole
Okay,
system.
okay, very good. I hear that quite often. Microservices are great because they are easier to maintain. You have smaller pieces, and as we all know, smaller pieces are less complex, so they are simpler to maintain. Well, they are simpler to maintain if you just take a look on a single microservice. But if you think of the overall solution, then these things are not simpler to maintain. Because many people think, hey, if I have only my microservice, I do not have to care about their microservice over there, so I can break whatever I want to break. No, you can't, because you communicate with the service. If you break something, something is going to break in the overall software. And the problem with microservices is that it's harder to detect. If you break something in a monolithic application, let's think of a C#, Java, Node.js, TypeScript, Ruby, whatever application. If you rename a method, who will remind you that this was not a good idea? The compiler. When will the compiler remind you that this was not a good idea? At compile time. Very good thing. Imagine you rename a REST endpoint of a RESTful web service in a microservices environment. Who is going to remind you that something was broken? The customer. When will the customer remind you? Not at compile time, at runtime, in production. He will tell you that problem at 3 o'clock in the morning, and you will have to get up, run into the office and fix something, and this is something that we do not want to do. So overall, microservices solutions are not trivial. I would even say are more complex to maintain. But the single item is easier to maintain. That's true. And now we are getting directly into my today's topic. Because if you want to succeed with microservices, you have to have mechanisms in place that ensure the healthiness of the overall system, that go beyond the single microservice. And for that, we have to talk about DevOps. We have to talk about DevOps practices. But of course, you are right. Many customers, they think that they are easier to maintain. But the problem is, I can tell you that, if you go to a customer, to a larger enterprise that used to work with monolithic system, and they do not have proper DevOps and cloud practices, their monolithic projects, at least the first ones, will fail. Because they think that it will be easier to maintain. They do not do things like automation and things like that, and therefore they will break a lot of things at runtime, and the overall stability will go down, at least a little bit, at least at the very beginning. Any other thing why microservices are so interesting? Maintenance is not the most important thing. Do you have an idea? Or, yeah?
It's easier to split the workload between teams.
It's easier to split workload between teams. Yeah, I like that one. It's definitely easier to split workloads. And why is it easier to split workloads? Well, it is easier because the systems are not so tightly coupled. If you have a large monolithic application written in Java or C#, and then you have this one team, you are working in this team, you go to that customer, and that customer is using, oh my God, .NET 2.0. That's ancient, that's a dinosaur, and you would like to change that to .NET Core, for instance. The problem is, in a monolithic system, if you change something here, it has to be changed here too, because everything is a homogeneous big thing where everything has to be on the same technological platform. Therefore, we have dependencies. Dependencies between modules that are only tightly coupled from a content perspective, but technologically in a monolithic systems, they are very closely coupled, and this is what we do not want to have. So this is the main argument for microservices. We would like to split the monolithic application into pieces, and these pieces communicate with technology and platform-independent standards. So we can easily pick one component and replace it with a different technology. For instance, you replacing .NET 2.0 with .NET Core. Nobody else around you will care because they only communicate with you with platform-independent standards. HTTP, AMQP, any other platform-independent standard. So this is a very important one. Choosing the right level of coupling. Yeah, I would agree to that, definitely. The big problem in that area is, you mentioned it, you want to separate teams. When we think about microservices, we always think about how do we split the monolith. And in many companies that come from the monolithic area, they think in layers. Yeah? Monolithic systems are like ogres. Have you seen Shrek? Ogres are like onions. They have layers. And software is like an ogre. They have layers. You have this data layer and the data access layer and the business layer and the service layer and the UI layer. And many teams, when it comes to microservices, split the monolith based on layers. So suddenly you have a data microservice and a data access microservice and a, I don't know, a business layer microservice and a UI service, whatever microservice. And this is exactly not what we want to have. Because our goal is to have autonomous teams. Teams that can make decisions on their own. And that only works if the monolithic system is split based on business areas, so-called bounded context. One team is responsible for one business topic. Of course, inside the microservice, you will have layers, definitely, but the team itself has the possibility to decide how to structure their microservice. And if one team says, I would like to use, I don't know, MongoDB because I need a NoSQL database and I would like to have a Node.js backend, I would like to have React in my front end or something like this. And the next team says, no, I am very much into Python and I'm using a relational database like Oracle, and on the front end we write, I don't know, a Java front end, could be, then they can do that. They are autonomous in their technology decision from the very bottom, the database, to the very top. Well, the UI is a little bit special, and we could spend another day talking about UIs in the context of microservices. This is out of scope of today's talk. But the goal that we have to keep in mind is that we have to have autonomous teams. And now we have a slightly bigger problem in traditional-oriented organizations. Because autonomous teams today, if you think about software developers, they are very good in writing code. But if they are autonomous and they can make their own decisions, they are responsible for everything. They can decide their base infrastructure, maybe even parts of their hardware, but this is not where they are really good at. And what's going to happen is that you will get a big mess. Because everybody is doing something differently, and it will, what should I say? The big, beautifully aligned data center doesn't look like this, but we get something like this because every team is doing something else, and nobody really knows how to run, I don't know, a Mongo database. Imagine you are CEO of a big company. You get into this company, currently you have this monolithic application with a single big Oracle cluster, then a single Java backend, and then a single monolithic user interface on top. Everything is neatly aligned. It looks, well, this is just a picture. It looks something like this. And now your teams come to you and say, we want to have something like this. We want to have Mongo, Oracle, SQL Server, Postgres, I don't know what. We would like to program. The one says in Node, the next in Python, the next in C#, the next in Java. It looks something like this. How do you want to solve that? Imagine you are responsible for running the infrastructure highly available and secure. Currently, in big companies, they know how to maybe run an Oracle database. And now they should magically know how to run Oracle, MySQL, Postgres, SQL Server, Mongo, I don't know. Where should they get the knowledge from? Now they should simply magically know how to harden a Linux server, a Windows server, a Node.js environment, a Python environment, a Ruby environment, an Erlang environment, I don't know what. The admins, they will get crazy. In today's day, I mean, let's be honest. We are a rare species. There are too few technical specialists out there on the market. So typically the IT department are understaffed. And now we come with a technology and a concept like microservice that will lead to enormous more administrative tasks. That's a big problem. We have to change something. We have to change the organization in order to get from here to here, but at the same time apply the microservice principle and autonomous teams. And here we have to talk about DevOps. We have to talk about how we can bring operational skills and software development skills together in joint teams to get us more productive. We have to keep Conway's law in mind. I don't know if you know that. That was a guy, I think in the 1960s, something like this. He said approximately something like this: every system that is built by an organization reflects the organizational structure. So if you have a traditionally very tightly organized organization, very hierarchically, very monolithic thinking, where you have a lot of, policies in place, where you are forced to use exactly that compiler and exactly that version of Visual Studio and exactly that version of Node.js and Oracle, and you have lots and lots of papers with all these security policies and so on. This is a kind of organizational pattern, and if you come into a company like that, and you would like to apply microservices in an environment like that, you will drastically fail. It will not work. What you need to do is, in order to make microservices successful, first and foremost, change the organization. Many companies that go into microservices are looking at technological solutions. They are trying to find this great framework or pattern or architecture or design that solves their problem, and it's just technologically viewed. But this is wrong. Following Conway's law means that we have to change the organization either before we go into microservices, or at least in parallel to changing the microservices organization. And one of the most important organizational changes is that we have to bring operations people and dev people together, or make dev people accept that they have certain operational tasks, or make ops people accept that they are now developers. They are no longer taking network cables, plugging them in, but they are now experts in Bash and PowerShell, because this is how in the future they will define the networking, using software and code and not hardware. This is a very important prerequisite in order to be successful with microservices. So what does this DevOps thing really mean? Let's take a look at the 4 parts that are mentioned here. The first one is the plan and track thing here. Planning and tracking means that when we run DevOps, we also apply agile principles. So we do not do big design upfront, waterfall project management, but we plan based, for instance, on user stories, agile mechanisms, agile methods, and things like that. This is what we start. And then even the system design, the whole development happens in a team that has operation skills and development skills. We do no longer take the software developers, put them in a room, and then they come out with a software design where they do not think about what that means to run this software design in production. On the contrary, they are in a DevOps team, and that means you build it, you run it. If they decide to use a MongoDB database, they know that nobody is going to run the MongoDB database for them. They are responsible. You build it, you run it. In the past, the classical enterprise that you still find today outside in the outside world, you always have the software development people who build crazy software architectures. They write not always the best code, And then they write long Word documents with installation requirements, and then they put everything to the admins and say, install it and run it. And if something breaks at 3 a.m. in the morning, fix it. Don't call me, because I'm a software developer, and I used to come to work at, I don't know, 11 a.m. in the morning, because I don't like getting up out of bed that early. You know what I mean? That is no longer the case. If we want to be successful with microservices, if we want to give the autonomy to the development teams, then the development teams have to be in charge. And that's not simple. That means in many enterprises, changing the culture. It means changing the enterprise, the organizational culture. It's no longer these admins and we software developers, or these crazy developers and we admins, we know how to run things in a stable way. It's no longer we admins always say no and we turn off any internet port because these software developers are so crazy and they do so many things wrong. And the software developers, on the other hand, they always fight with the networking people because they don't talk to each other and nobody understands the other side. I think you get what I mean. This is a cultural change that has to take place in order to develop architectures and designs and to take responsibility. In successful microservices organizations, if you start in a successful microservice organization and you are in DevOps team, you will be called if your production system breaks at 3 a.m. in the morning. It's not the admins. The admins will be called if the climate control goes out, if I don't know, if a squirrel eats your internet connection and your whole office is off the internet, then the admins come into place. Or if the large disk array breaks, or if you have a fire in the data center, that's the kind of admin work I'm talking about. There you still need specialists, of course. Now, once we have this development and testing stuff here, it goes into release management. And now we have to talk again about the whole idea of microservices. You said it's easier to maintain. You are right. From the point of view of the single DevOps team, it's easier to maintain. But I would like to paint a picture in your mind. Think of an overall ERP system. An enterprise resource planning system that you are responsible for, the entire system you are responsible for. And it consists of, let's say, 50 different teams with 50 different microservices. Each team, let's say 5 people, 250 developers, you are responsible for the overall system. If each team deploys, let's say, once a day, and that's the kind of cadence that many teams are trying to reach. If they deploy once a day, then we deploy 50 different production systems every single day. Will they deploy at the same time? No, of course not. They will deploy at different times. They will deploy in different environments, using different technologies, using different databases, using different programming frameworks and platforms. You are responsible for the overall stability of the system. What do you think is your #1 priority in that area? Stability and automation. Automation is key. If you want to survive in a microservices world, everything that has to be done at least 2 times has to be automated. I would go even further. If you do a one-time administrative task, it's easier to write it down in a script and execute the script because the script is your documentation. You do not have to document whatever you did if you wrote the script and put it in source control. If you have to do something twice, or every week or every month, it is an absolute no-go to do that manually. Automation is key. And what do you think? We as traditional software developers, are we great in automating things? Well, no. Who do you think is very good in automating stuff? The ops people. They know how to run regular jobs. They know how to monitor systems and I don't know, ring an alarm if something goes wrong. So again, we need the DevOps practice in order to make this thing work. So automation, as a very core pillar in the idea of DevOps, is of critical importance in that area. Next one. If you are responsible for this ERP system, for this large one, okay, what is your number 2 priority after making sure that not every day something breaks? By the way, I have a motto for this, we deploy frequently and release stuff. It's not from me. I heard it years ago in a video documentary from, it was an interview of a senior system architect from Microsoft, and he said his motto is, if something hurts, do it more often. That means if you break something, whenever you deploy a new version to your data center or your customers, do not reduce the number of times that you deploy. Do the contrary, do the opposite. Increase the cadence. Do it more often. If it hurts, do it more often. Because what will it enforce you? It will force you to automate this stuff. Because you do not want to get hurt very frequently. So if something hurts, do it more often, and that will force your teams to automate. Okay? That's a very nice motto, and I really like that. I often meet customers who tell me, well, now we ship our software once every 6 months, but it's really a pain in the, you know where, testing all this stuff and so on. It's much too expensive, so what we do in the future, we will ship only once a year. And I always tell them, no, do the opposite. Ship every quarter, ship every month, ship every week, and at some point in time, go to software as a service. Deliver your software in a way where you can roll out your software every single day, and if you want, in the middle of the day, and nothing is allowed to break. I'm sure many of you have read the white papers about Chaos Monkey and things like that at Netflix. There are big companies out there who have proven that this really works on a very large scale, and I encourage you to read these papers. They are very, very interesting. Next one. Monitoring and learning. This is your number 2 priority. If you are responsible for this large operating ERP system, you want to know what's going on. Traditionally, in a monolithic system, you have this one database cluster. 3 machines, you know them, you know their problems, you know their strength, and then you have this web cluster with your, I don't know, business logic services, blah, on it. 3 servers, you know them, you regularly connect to them, you have a kind of relationship to them. Do you know the concept of pets and cradle? Cradle means, I don't know, if you are a farmer and you have 200 cows, that's cradle. Pets, I have 2 cats, and I have a different relationship with my 2 cats than the farmer who has 100 cows. In a traditional monolithic system, you have pets. The servers, you know them, you have a relationship to them, they are old, you installed them 3 years ago, you saw them growing, and you were there when they had their first, I don't know, sicknesses and things like that, and you installed the patches. This is the kind of pet relationship that I mean. In a DevOps world, it's completely different. Now you have 50 different teams, or I don't know how many teams. Everybody has its autonomous system and is responsible for his own thing. And therefore, you need to monitor the overall thing. It's not enough to just take a look at a certain server and look into a log file. You suddenly have 50 or 100 or hundreds of very small servers, and they are primarily owned by somebody else. You don't know the server anymore. So monitoring is a very different beast when it comes to microservices, and especially when it comes to DevOps. Log files in a folder are no solution anymore. You need something different. You need agents, you need distributed computing, you need a kind of platform that gathers these logs and that give you an immediate overview about your system, where you see with one glance, is my system healthy? And if not, where is the problem? Why is there a problem? And what can I do to fix it? Who do I need to call and wake up at 3 a.m. in the morning, ideally automatically? You know how that works with the large cloud data centers? You know what happens if something breaks in the Azure cloud? That's Microsoft's huge worldwide spanning cloud. It happens that I know it quite well. The other data centers, I'm quite sure that Amazon and Google, they are doing probably something similar. If something breaks there, the admins do not call somebody manually, but they have automatic telephone systems where they know what has broken, who is responsible. They automatically inform the necessary people. These people can immediately get into a phone conference, do some triaging and things like that, because they have to guarantee numbers like 99.99%, and they do not have the time to do anything manually. They train that stuff. They run test alarms. The telephone system is allowed to do some kind of integration tests if you want. So they are running test alarms at 3 a.m. in the morning where they randomly place in some white noise so that people can't understand each other, or where they cut certain lines in order to make it realistic. What happens if these things have to be trained, automated? Of course, they are working on a very large scale. This is not necessary for every small company. But for me, it makes me feel good if I know that, in my case, my servers are in an infrastructure that is maintained like that. Still, even on a smaller scale, we have to consider monitoring. Learning, that's another thing. In most monolithic applications, the software is developed based on the Hippo Scheme. You know that? Highest person's opinion. Highest income person opinion. So that person in the room who is paid the most can tell where we spend our money and which features are developed first. That's, of course, obviously, that doesn't make sense. If we work in a microservice environment, and if we have some very mature monitoring system in place, we cannot only gather data in terms of what went wrong, but we can also gather data that tells us who is using which feature, how often, what is the real world response times that my customers see, and where do I need to put actions. And that's another core pillar of DevOps. It's not designing a system based on your gut feeling, it's based on real world evidence gathered in production systems. That's the idea of learning in that area. And I can tell you, in many monolithic systems, which are not organized in a microservices and DevOps way, the Hippo principle is very strong. The software development teams try to prioritize their work. Based on what? Based on the gut feelings of some magic product owners who know everything about their customers. In reality, that's not true. In many cases, features are implemented, enhanced, fixed, optimized that nobody needs. Nobody ever uses that function, and we pump a lot of money into it. And the software development people don't know about it because they are not allowed to access the logs, because maybe it could be of the crazy GDPR stuff or whatever. Because of security reasons, they don't know who uses what. In a DevOps world, where you are responsible for running your own system, you have access to these logs. And now you have evidence from the production system. And now you are responsible in your microservice, which is business-oriented, not technology-oriented, to optimize for your real-world end customers. That's a very important principle in that area. By the way, another thing is here important when we talk about DevOps. The only environment that counts is the production environment. Production first. In a microservice world with DevOps principles, I never want to hear again, well, it works on my development machine. I have no idea what's wrong in your environment, dear customer. I don't want to hear that. If you work in a software as a service business, for instance, the only system that counts is the production. It's fast in your test lab, but your customers are complaining of poor performance. In the classical organization, the developer says, it works in our labs, The ops people say, we don't see any problems with the IOPS and the memory utilization, and the customer is sitting in the middle and has a problem. In a DevOps world with microservices, where you are responsible to run your microservice, you are going to be called every single time when the customer is not happy with the performance, for instance. Okay, so another important one. And then we go from this learning stuff, we go again into the planning thing where we prioritize work, then we develop, then we release, and this cycle is going fast. This innovation cycle means that we do some coding and we ship it on short term. In the classical world, you have shipment cadences of, I don't know, once a month, once a quarter, something like this. In a DevOps microservices world, you ship every day, maybe 10 times a day, maybe, I don't know, 20 times a day, whenever. There are no patches anymore. If there is a bug in the software, hey, in 2 hours we deploy. Every 2 hours we deploy, so we don't need patching. We just have a new release. Do you get the idea? What do you think? Does this work on a larger scale? Take a look at Visual Studio Team Service, one of the, well, the world's largest Git server in the world. They deploy, I don't know, a dozen times a day. If they create a new feature, if they are working on a new feature, they are not making a branch, developing it in this branch, and then they are keeping this branch for weeks until they finish this feature. They don't do that. They very frequently integrate and deploy. They deploy features which are half done. However, in the code they have an if statement where they turn off this feature. This is called a feature flag. They very frequently work with feature flags, but they ship. They want to have a consistent flow of customer value. Think like that. In a microservice environment, every single code you write is a dead investment if it's not outside at the customer side. If you write some code and it would make your customer's life better, but it is not in the production environment, it is wasted effort. And we do not want to waste effort. The minute that we create something useful, we want to have it outside at the customer site, not months later. This is the reason why we need this automated cycle. Yeah, I talked about that. Automation, maybe you have read stories about Tesla and Elon Musk, and he did a quote, he said something a few weeks ago that they underestimated the human factor in automating production. And to be honest, we in a DevOps world, in a microservice environment, we are to a certain degree in the business of automation. Yes, we are software developers, but we are also automation experts. Our robots do not look like that. Our robots are PowerShell scripts, Bash scripts, I don't know, Jenkins build servers, VSTS build servers, GitHub processes, whatever. This is what we do. This is a Bash script that you maybe have to create. The point that I want to make is that Elon is perfectly right. Automation is really hard. Well, we are in a little bit a better situation than a company like Tesla because we do not have to deal with hardware. If we want to automate something, and if we want to have a new robot, we just change a few bits, a Bash script or a PowerShell script, and we can immediately deploy them. Getting a new robot like that isn't done overnight, isn't that easy, and these things are not that easy to fix. So it's a little bit easier to automate in a software world, but still, automation is in many cases underestimated. And this is, I want to go back to your argument. In a microservices world, is it easier to maintain? Well, yes, it is easier to maintain from a single microservice point of view. But the amount of time and effort that you save in that area, you have to invest it into automation. And therefore, in my experience, microservices are not easier to maintain from an overall perspective. But what you can get out from them is you can get faster innovation, you get more innovation, you get more customer-centric solutions, and this is what we really get. So we invest the same amount of money, but at the end of time, we want to have more from that money. But we must be willing to invest in automation. And many companies that I work with, they are quite good in software development. They are quite good in administrating production systems, but they are poor in automation because they have trained for many, many years and decades how to do things manually based on paperwork, on forms, on Word documents and things like that. And now I come in and say, forget your Word document. If you want to put something into production, don't write it down. Automate it using some kind of scripting technology. And that's, again, a mind shift. Now let's switch gears a little bit. In many companies where I am at that come from this monolithic age and that currently have these big servers and small data center rooms and so on, they think in hardware data centers. They think in something like that, in switches and laying cables and installing, I don't know, software and hardware in their data centers, and this is where they think. But to be honest, in a microservice world where the environment is constantly changing, and especially in a software as a service world, this doesn't scale anymore. This has to be there, I agree to that, but to a large degree, it has to be code. If I need a new server, I must not wait until Dell, HP, or somebody else ships this new server. It has to be a REST API call to some kind of private or public cloud, and seconds later, I need to have this VM or database or runtime environment or whatever. I give you an example. In my core company, Software Architects, we have two companies, but in the Software Architects company, where we do software as a service, we currently run approximately 250 database clusters. 250 database clusters, each cluster consists between 3 and 5 machines, SQL Server clusters. Do you know how many admins we have? 0. Do you know how many time we spent last year installing, patching these things, keeping the firewalls up to date, checking that the database updates work, that the backup strategy works? 0 minutes. That's platform as a service, that's infrastructure as code. For us, it's as easy as creating a file on disk to create a database cluster. And the same is true for a web server, for a Node environment, for a Python environment, for a Ruby environment, for a C# environment. We just go into the cloud and say, give me that environment, and I just want to use it. And this is what I mean with infrastructure as code. If I need a new firewall, I do not buy it and install it in a rack. I send a REST request to some kind of resource manager in the private or public cloud, or I fire up a statement in a Kubernetes cluster if I run it locally based on Docker technology, for instance, and this is what I get. And I can't see the infrastructure anymore. It's a flat network, it's a flat number of servers, and the software design or the system design is no longer visible in the hardware world. The hardware world is just a pool of resources. The things that are interesting for me are written down in JSON files, in Bash scripts, in ARM templates, in XML files, and the hardware layout, the network configuration, the database cluster configuration, the backup scripts, and all the things, they live in source control. They are maintained like C# code, like Java code, and they have the same rhythm as source code. The ops people are 100% developers. Their programming languages might be different than the ones who build the, I don't know, service layer or data access layer. But still, they are creating source code. And if they, I don't know if you ever worked with Kubernetes, for instance, Docker, Kubernetes, maybe you've heard about that. If you want to change something there, you change something in a WAML file, in text file, you check it in, and an automatic build creates does the changes in your underlying infrastructure, changing the network policy or whatever. You never touch any kind of hardware. That's, again, something that has to change. Imagine you start to work in a large company, monolithic thing, very hierarchically organized, hundreds of years in business, and then you find this big data center there and you start to work there, and it takes you 6 months to get a new virtual machines because the admins have to buy a physical server when they want to give you a new virtual machine. That's horrible, but that's the reality in the majority of customers. And I can tell you, I had that a few months ago. I worked at a customer, and I knew this customer was 100% in the public cloud, in the Azure cloud. I know that creating a VM in the Azure cloud takes, I don't know, 30 seconds, something like this. And I asked them, hey, I need for a test environment a new virtual machine. You know what they told me? It will take 3 months. Huh? 3 months? We are talking Azure here. Why 3 months? Well, only one person is allowed in our company to create a VM, and this person is currently on holiday, and he will get his first daughter in a few weeks, so he will be on maternity leave for the next I don't know what, and this is the reason why you have to wait for 3 months. This is what I mean with organizational structure reflected in the software architecture. In a microservices world, I give each autonomous team their own part of the private or public cloud, and they can maintain it themselves. And they deal with hardware just like they deal with everything else. It's software, and they are responsible for themselves. The difficult part is how to enforce certain rules and policies which are necessary. No question about that. You maybe have some legal restrictions. You have a GDPR, a General Data Protection Regulatory, that you have to enforce if you are responsible for this whole environment. So giving this level of freedom, autonomy to your teams, while still enforcing some enterprise policy, is a very difficult task. And it is a task where many companies and also researchers think a lot about how you can bridge this gap between full autonomy and policy-driven, very strict hierarchical organizations. It's a dance somewhere in the middle, and you have to find a nice balance. This is difficult. It's not trivial. Because in a hardware world, you can just lock up the room and nobody can go into it. How do you do the same in the software world? This is from a marketing slide from Microsoft. I will not go into the very much details here, but I think it brings to it really nails down a very important concept here. Because especially here in Europe, we are still very conservative when it comes to public cloud. But if you think of what I told you in the last 45 minutes or so, I told you a lot about change the organization, doing things like in software, and encouraging your teams to make technology decisions, but doing that on-premise in your own data center is very, very expensive. And what I see today in the business out there is that many, many companies, they say, no, we are not going into the public cloud. We do not want to give our valuable data and code to companies from the US, like Microsoft, Amazon, or Google. We want to keep everything in-house. And what they indirectly say is, we do not do DevOps, we do not do infrastructure as code, we do not do rapid innovation cycles, and that's really a pity. If you want, the world is heading towards microservice, DevOps, and all the things that I told you. No question about that. And you have two decisions. Either you do that with the lowest amount of investment, then you have to go into infrastructure and service, even better platform as a service and serverless in the public cloud, so that you let Microsoft, Amazon, and Google worry about the technical details of the data centers, soft infrastructure as code, and things like that. Or if you really decide that you want to keep your infrastructure in your own company, then you have to make the next step. Then you will have to hire a lot of DevOps specialists. Then you will have to invest in things like Kubernetes or other things, and you will have to change your data center infrastructure, and that's very expensive. It's, in my point of view, the wrong decision to say no to the public cloud, yes to all the concepts that I told you, but no to any investment in changing the organization and the base infrastructure that you need to encourage that. So for me, it is clear. I live and breathe for the last 10 years in the cloud. We couldn't afford running 250 database clusters in our own company. We are 6 people in the core company. I am one of them, and I'm I'm traveling a lot, so I'm not there. One person is caring for the whole internal organization, so 4 people are left in the company. Do you not think that these 4 people can do the development, do the consulting work, and care for 250 database clusters, and I don't know, 25 web clusters and things like that? No way. That wouldn't work. We would have to hire, I don't know, another 10 people if we want to do that on premise. So we cannot afford that. Very simple. The whole idea of everything that I told you in the last nearly an hour is our goal is that we want to focus. Microservices, DevOps, agile development, they all go into this one word, focus. Focus on the customer, focus on the production environment, focus on delivering a constant flow of innovation for our customers. Everything that distracts us from focusing on that goal, we want to get rid of that. I am not paid for installing a SQL server, an IIS, a node cluster, or a reverse proxy in a Docker container. My customers pay me for added value, for writing code that helps them solve their problems. And I would like to focus on that. And for each and every company out there, every company has to decide what their focus is. And the smaller the companies are, the narrower the focus has to be. So maybe some of you will leave the university and found their own startup, for instance. You will probably not have a lot of money when founding your startup. This is the reason why many startup companies love the public cloud and microservices and so on, because the whole serverless and PaaS thing, it allows them to focus on the code. They are not distracted by having to care for their own data center and things like that. But if you go on a larger scale, in larger enterprises, mid-sized enterprises, many of these companies have lost the focus on their core business. It's not IT, it's not operations. It's building software or building other products where software is a big part of it. And therefore, they have to think of how can I solve that. And yeah, microservices, DevOps, and especially the public cloud can help them be successful. If the company is large enough, think of insurance companies, banks, and so on, then they can maybe build their own private cloud because they are large enough. They can afford having specialized DevOps teams who can build data centers like that on premise in their own basements. That's perfectly fine. But you have to have a certain size in order to be able to afford that. So, if you take anything away from this guest lecture, then remember that microservices is all about autonomous teams. It's not so much about building components. Components is so cold, so theoretical. The core idea of microservices is that you encourage and enable teams to work in an autonomous way. They make their own autonomous technology decision, their own designs. They decide what's best for their business environment, for their bounded context. And in order to reach this goal, we have to manage complexity. Manage complexity because we do not have a homogeneous big monolithic system anymore, but we have, let's say, a colorful mixture of technologies, architectures, designs that has to somehow work together. And in order to be able in order to enable that, we need to combine microservices with the DevOps principles and the cloud principles that I was talking about in the last hour. With that, we have, I think, 5 minutes left. I hope you could take away something from the last hour, and I'm more than happy to answer some questions or to have a discussion with you. Thank you at that point for having me here. Thank you for listening to me, and I would like to open it up for questions. Thank you.